Homework sheet U9, question 1. In this question we're asked to differentiate x equals sec squared 3y to find dx dy, giving our answer in terms of y. This is a question about the chain rule. In fact, it's repeated uses of the chain rule. I've rewritten my expression as x equals sec 3y all squared because I want to do the substitution u equals sec 3y. And this gives me x equals u squared, which is much easier to differentiate. dx du is simply 2u. And I can replace my u term back with sec 3y. I also then need to differentiate u with respect to y. Now this is another application of the chain rule. If you're more confident with the chain rule, you can do this without the extra writing I'm about to do and go straight to an answer. But if you're less confident, then you can make another substitution that w is equal to 3y. And then I just have to differentiate u equals sec w. If you look in the formula book, you can find that the differentiation of sec w is sec w tan w. So this is my value of dw. And if I substitute back for w, I get sec 3y tan 3y. The reason why I did it as multiple steps of the chain rule is a lot of people would forget to times by 3 if they went straight to a du dy answer. This comes from differentiating w with respect to y. dw dy is just 3. To finish off, my answer for dx dy is dx du times du dw times dw dy, and if I times all three of my parts together, I get 2 sec 3y times sec 3y tan 3y times 3, which I can simplify as 6 lots of sec squared 3y tan 3y. In part B, I need to use my previous answer as a starting point to show that dy dx can be written as 1 over 6x lots of x minus 1 to the power of a half. Now I can replace sec squared 3y with x, as that was the original definition that was given at the start of the question, but the tan 3y is going to be a bit more tricky. I need to use trig identities that I can use the fact that tan squared 3y is sec squared 3y, take away 1. Now I know that sec squared 3y is x, so I get tan squared 3y is x minus 1, and if I square root both sides, I get tan 3y equals x minus 1 to the power of a half. I can then substitute this in to my previous answer. I can replace sec squared 3y with x, I can replace tan 3y with x minus 1 to the power of a half. Now the relationship between dx dy and dy dx is a reciprocal one, so dy dx is 1 over dx dy, which is therefore 1 over 6x x minus 1 to the power of a half, as required. In part C, I've been asked to find an expression for d2y dx squared in terms of x, giving my answer in its simplest form. For this question, I'm going to have to use the quotient rule. I set my numerator as u and my denominator as v. So u equals 1 and v equals 6x x minus 1 to the power of a half. I need to differentiate each of these terms. du dx is easy to find, that's just 0. dv dx is going to be a little bit trickier, as I'm going to have to use the product rule for that. I'm going to do a little bit of an aside, where I'm going to set f as 6x and g as x minus 1 to the power of a half. I don't really want to use u and v again because I've already used those letters before. df dx is 6. dg dx requires the chain rule. I'm not going to go through the full notation and add another letter into this problem. I'm just going to do half lots of x minus 1 to the power of minus a half times by the differential of the bracket, which in this case is just 1. Combining these together, my expression for dv dx is equal to f lots of dg dx plus g lots of df dx. So that gives me 6x times half x minus 1 to the power of minus a half plus 6 lots of x minus 1 to the power of a half. I want to simplify this. I can take out a common factor of 3 from the 6 times half, and I also want to take out a common factor of x minus 1 to the power of minus half, which I'm going to write as a denominator of a fraction. This leaves me with x lots of the first term plus 2 lots of x minus 1 in my second term, because if I multiply out x minus 1 divided by x minus 1 to the power of a half, I'm going to get the x minus 1 to the power of a half that I require. And if I simplify the part inside the bracket, I get x plus 2x, which is 3x, and I take away 2 for my constant term. And I fill that bit back up here at the top. Now that I've worked out my 4 terms, I can start with the quotient rule. dy dx is equal to v du dx minus u dv dx all over v squared. I can substitute in all my previous answers that I got before. V du dx is 6x x minus 1 to the power of a half times 0, so I'm just going to put a 0, minus u, which is 1, lots of 3 over x minus 1 to the power of a half times 3x minus 2. This is all then divided by v squared, which is 6x squared, which is 36x squared, times x minus 1 to the power of a half squared, which is just x minus 1. Now I want to simplify this expression as best I can. I can take the minus from the top and swap the terms around inside the bracket to get 3 lots of 2 minus 3x. And I can bring my x minus 1 to the power of a half down to the denominator to combine that with the x minus 1 on the bottom to get 36x squared x minus 1 to the power of 3 over 2. Last thing is there's a common factor of 3 on top and bottom, so I can simplify my answer to finally get 2 minus 3x over 12x squared x minus 1 to the power of 3 over 2.